A very good morning, my dear students. Welcome back again. Today's video will be the last video for the chapter heat. That is the part that will be there till for your unit test 3, right? So in the previous class or in the previous video session, we have discussed about certain effects of heat, right? Today we'll be discussing some more. Now, you must have seen that between the two electric poles, the electric lines of the telephone wires getting swagged down during summer, or during winter, those same telephone wires getting tightened. This is due to the expansion due to heating and contraction due to cooling. Now in summers, what happens? The wires get heated up due to the heat of the sun, and when they get heated up, they show thermal expansion. That is, they show an expansion in length. In terms of length, they show linear expansion. So thus what happens? They swag down. They sag down during summer. The reverse thing, or just the opposite thing, happens during winters. That is, since the outside temperatures fall down, they get cooled, and thus they show contraction in terms of their length, which is why they get tightened. Now the question is, if someone thinks of laying the wires during summer, how that person must lay the wires? Will that person lay the wires a bit loose or tight? Now the fact is, if the wires are laid in summer tightly between the poles, what will happen during winter? That same wire will further contract, and thus they may collapse because they will further contract. So if the wires are laid in summer, they should be laid a bit loose, but not so loose that they'll sag down more. Understood? So they must be laid down a bit loose so that the contraction during winters may be allowed. The same thing, if the wires are laid in winters, they must be laid tight, because in summer they will show expansion and they will sag down a bit more. Now if the wires would have been laid lightly or loosely, what would happen? It would show more sagging down in the summers. So to prevent that, if the wires are laid in winters, they must be laid tight in between the poles. But if the wires are laid in summer, they must be laid down a bit loose so as to provide space for contraction during winter, right? Okay. The next thing is about this diagram. We have or you, some of you or some classmates of your class have done this experiment along with your senior batch the previous year in science exhibition. Not previous year, the year before, right? This is the bridges that are laid on rollers, which you can see here. Now, if the bridges would have been fixed tight to the pillars during summer, they would have shown linear as well as cubical expansion as well as superficial expansion. Now, they would not have got space to show that linear expansion. So, what would happen? They would collapse the two pillars. Understood? So since the rollers are placed and a bit of space is left here, the bridge, after showing a linear expansion as well as superficial expansion, they can roll or get some space for their expansion. However, even the the girdles are also placed in between the whole bridge, because they will also show expansion in between, that is superficial expansion. Thus, to provide space for the superficial expansion, the girdles are also placed in between the bridges such that the bridge may not collapse. Right. So again, another thing, that is whenever we place water in a thick water glass tumbler. Now we know that glass is a very bad conductor of heat, right? So if the glass is thick, for example, something like this, and we pour hot water into the thick glass tumbler, it cracks. Why? Since the glass is a very bad conductor, when hot water is poured in the glass tumbler, this inner wall tries to expand. However, it fails to conduct the heat to the successive layers. But this expands and it tries to find the space, but it doesn't get, because the other layers do not get the heat that this layer has got, since glass is a very bad conductor of heat. Thus, due to this reason, the full glass tumbler, if it is thick, it cracks down when immediately or within a certain or a very short span of time when hot water is poured into the glass tumbler. So in this case, we should use some other types of glasses which will not crack, such as borosilicate glasses. Next is about the measuring tapes, where the metal that is not the metal, it is actually an alloy. It is used invert, which is an alloy of iron and nickel. Now it expands very less, because if any material is used for making the measuring tape, we must keep in remember that it must not show linear expansion, because that will lead to wrong measurement of the things. Right, because we use measuring tapes for measuring lengths. Now, if the material with which the measuring tape is made, that shows linear expansion, then it will give a wrong reading. So, we have to keep this in mind, that for making measuring tapes, a material must be used which will show very little expansion, very little thermal expansion, and that too linear thermal expansion. So for this reason, measuring tapes are made using invert, which is an alloy of iron and nickel. Next, you must have seen this in case of railway tracks. Small gaps are left behind. Small gaps are left in between the tracks, railway tracks. It is because in summer, since they are directly under the sunlight, they will get heated up and they will show linear expansion. So if they do not get this much space for their expansion, what will happen? The railway tracks may bend, which we have studied in case of bimetallic strip, if you remember, that since one of the metal expands more than the other, the strip bends. So similar case would have been observed in the railway tracks if these small gaps would not have been left behind. The railway tracks would have bent due to thermal expansion, and if the railway tracks bend, then a moving train would get derailed. So that would lead to hazardous damage, isn't it? Such a huge accident, if we think of even. So to prevent this type of accidents, small gaps are left in between the railway tracks to give some space for expansion in summer and also certain space for expansion in winters, right? Even in between the railway tracks, these wooden slabs, not wooden, this metallic slabs are also placed, where also the gap is left behind. Now, these were all about the effects of heat in case of solids. Now, in solids, the effect of the heat, that is the thermal expansion that is being observed, is a bit less when compared to liquids and gases, since the forces, intermolecular force of attraction in solids is very much strong compared to liquids and gases. So solids show very little thermal expansion when compared to liquids and gases. However, in liquids, since the molecules are free to move from their mean position, so when they absorb heat energy, their average movement or kinetic energy increases manifold, increases much more than compared to solids. So liquids show more thermal expansion than solids, and that is why this property of thermal expansion, which we see in case of liquids, is being applied in case of thermometers. We use mercury in clinical thermometers, and we also use mercury as well as alcohol in clinical and laboratory thermometer as well, because liquids show considerable or noticeable amounts of thermal expansion than solids. So this is why liquids are used in thermometers for reading, because when they absorb a little bit amount of heat, it shows considerable amount of expansion, thermal expansion. Now in case of gases show the maximum amount of thermal expansion, that is, they show cubical expansion. This is an experiment which we have shown in our science exhibition a year before. That is, you take an empty bottle which seems to be empty, though we know that this bottle is not empty because it has air. Then we place a balloon here. Now what do? We place this bottle in a tumbler, metal tumbler or a vessel containing hot boiling water. So that hot water will heat up the air inside the bottle and it will show expansion. And gases show maximum thermal expansion, due to which it will try to take more space. It shows more expansion, which is why it will start inflating the balloon. So by this experiment we can prove that gases show maximum expansion, and by this Graves ball ring and ball experiment we can show that solids show minimum expansion, which goes almost unnoticed. That is, an iron ball is being used here that just passes through a rim, a circular rim. Now when this iron ball is placed in hot boiling water, it expands a bit, and then when we try to pass the iron ball through the rim, it fails to pass. So this shows that solids expand on heating, right? And there is also an experiment, you can go through it, showing an experiment of the effect of heat in case of bimetallic strips. So children, we have completed till page number 73 of this chapter, and this is the portion till where your syllabus is for the unit test 3. That is, you have the previous chapter light and this chapter till page number 73. The rest of the portion will be there for your unit test 4, right? So be prepared with the lessons taught till now, and all the very best for your upcoming unit test 3. If you have any doubt, you may call me up at any time of the day, and we will also be meeting in our online class by the in this week, right? So thank you children for attending the class.